Hey, what's up, guys? And it looks like our chat is not working today again. I don't get it. It's like every other stream, it just doesn't work. And bear with me. I still have a horrible cold, which sucks, and my lights don't help my eyes. So if it looks like I'm about to cry, it's just my cold. But yeah, guys, I'm pretty excited. So today we are going over, let's see, keyword lists and maps. So that is really cool. We're going to go through some awesome examples on the Getting Started guide. And why don't we go ahead and jump right in? Oh, so I'm working on a little like daily dev cheat sheet that common commands that I always need to reference. So I put this together. It's been pretty cool. It's fun. And I'm going to be making this available for download in the next couple days. So that'll be cool. It's not too long. And I also think I want to make like a cool like wallpaper version of this too. I'm going to test my design skills out and see how cool I can make it look. But yeah, I think that's fun. I like having little cheat sheets that are useful available. All right, let us pull up Firefox and we'll go right into our Getting Started guide. So elixir-lang.org, guides, and keyword lists and maps. Thanks, Sasha. Yeah, I had a lot of fun doing it. I figured, I never spent time like consolidating it. I always use like the Notes app with like all my common commands, and I'm always going into Notes to be like, okay, how do I restart all my Docker containers and things like that. So I kind of put it all in, and then like Phoenix generators and things. So when should you use the generator.json, .live? So I put all that in there. So I feel like things like that, because you're not, after like creating a project, you rarely go back and create new schemas and things. So I feel like it's good references to have. So yeah, I think it'll be cool. And I'll probably use my guide all the time and I won't have to go into my notes app anymore. So keyword lists and maps. Now let's talk about associative data structures. Associative data structures are able to associate a key to a certain value. Different languages call these different names, like dictionaries, hashes, associative arrays, etc. In Elixir, we have two main associative data structures: keyword lists and maps. Keyword lists are a data structure used to pass options to functions. Imagine you want to split a string of numbers. We can use string.split arity2. Let's go ahead and pull up our terminal here and start playing along. All right, make this a little bigger for you guys. All right, let's start our Elixir shell with an IEX. All right, so we can use string.split and we can pass in a string. So 1, 2, 3. And then the second arity here, or the second argument, is what do we want to split it on? We want to split it on a space. And that gives us a list back of individual values. So that's cool. However, what happens is if there's an additional space between the numbers, so if we were to do this, put a space here and a space here and hit enter, now we have empty strings in our results. So luckily, string.split arity3 function allows the trim option to be set to true. So you can do things like this. We can keep those extra spaces in, and then we can pass in an extra options list with a key value trim set to true. And now when we hit enter, it trims off the extra spaces. Now, trim keyword or key value trim true list is a keyword list. Furthermore, when a keyword list is the last argument of a function, we can skip the brackets and just write the atom trim and true. So we can do this. We don't need the brackets. Boom, and we get the same results. So as shown in the example above, keyword lists are mostly used as optional arguments to functions. As the name implies, keyword lists are simply lists. In particular, they are lists consisting of two item tuples where the first element, the key, is an atom, and the second element can be any value. Both representations are the same here. So you see that we have a list with a two value tuple in it, and then you see we have a list with just the key value atom and the value here. And these are the same thing. So let's go ahead and just use our little match operator. And so we're going to have a list on this side with a tuple with the atom trim and value true. Okay, and this is equal to our list of trim atom true. And if you notice, the colon of the atom switches sides depending if it's being used as a key value or a key versus an atom value in a tuple, but they are still both atoms in these representations. And that's true, so they are the same. Since keyword lists are lists, we can use all the operations available to lists. For example, we can use the concatenation operator to add new values to a keyword list. So let's do that. Let's go ahead and... So we can create our list, set to a variable list, and let's just make a list here with a key A, value 1, key B, value 2. Hit enter, and then we can go ahead and just say list and then concatenate it or add it to another list with a key C and 3. And this is going to concatenate the value C or append it on the back side. So there we go. And we can also prepend lists. So if we go ahead and say we wanted to add keyword or key A and value 0, we can prepend it to our list as well. And as you notice, we, excuse me, we get it prepended, and we're allowed to have multiple keys that are the same thing. So you can read the value of a keyword list using the brackets syntax. This is also known as the access syntax, as it is defined by the access module. All right, so we can go ahead and grab values from our list by just going like this, and then in square brackets, we can pass in the key that we want, and we get value 1 back. So there we go. And then we can, list key B, and we get value 2 back. Now, in case of duplicate keys, values added to the front are the ones fetched. So it's kind of like order of operations here. Whichever one is found first, it gets returned. So if we're looking for key A, we're always going to get 0 back and not 1. Okay, so let's see. If we go back in, and we have to set this to a new variable so we have access to it. So we'll say new list equals. So now we have one with two keys that are the same. And so if we we want to retrieve key A, we have to use the right list. We have to use our new list. So key A, and we get value 0, not 1. So it always will grab the first one it finds. I'm going to clear this so we have some space. So all right, sorry about that. I had to cough. Keyword lists are important because they have 3 special characteristics. Keys must be atoms. Keys are ordered as specified by the developer, and keys can be given more than once. For example, the Ecto library makes use of these features to provide an elegant DSL, so a domain-specific language for writing database queries. We're not going to run through this example, but you can see here, you can create a query. So what's happening here is we're looking through the table weather, right? This is in a context file, most likely. This is where you put all your CRUD operations, but we are running through, and you can have multiple, basically you're looking for multiple keys. You want to make sure this PRCP is above 0 and temp is below 20, and then we're going to select this value that is in the weather table. So although we can pattern match on keyword lists, it is not done in practice, since pattern matching on lists requires the number of items and their order to match. All right, so let's go ahead and get some error messages. So we can pattern match with lists. A key and then variable A equals A1. So this does work, and then we have value A is 1. So pattern matching will work. It just it's difficult to know as long because everything has to match exactly. So if we were to try to pattern match with one key over here, like above, but then we try to pattern match a list with two values inside of it, like this, we're going to get a match error. and then so on. So if we also try to pattern match and things are out of order, so if we do key B, value B, A key, value A, and we try to pattern match to another list that doesn't have the same order, we do key A first, value 1, and then we do key B, value 2, we're going to get a match error as well. So furthermore, given keyword lists are often used as optional arguments. They are used in situations where not all keys may be present, which would make it impossible to match on them. In a nutshell, do not pattern match on keyword lists. In order to manipulate keyword lists, Elixir provides the keyword module. Remember though, keyword lists are simply lists. So they have the same linear performance characteristics. So the longer the list, the longer it will take to find a key, to count the number of items, and so on. So if you need to store a large amount of keys in a key value data structure, Elixir offers maps, which we will soon learn. So do blocks and keywords. As we have seen, keywords are mostly used in the language to pass optional values. In fact, we have used keywords before in this guide. For example, we have seen if true, do this, else do this. All right, so it happens that do blocks are nothing more than a syntax convenience on top of keywords. We can rewrite them above too. So we can actually write an if statement in its shorthand form. And when you write something in its shorthand form, you can do functions this way as well. So if we say if true, comma, do, this will be seen. And then we can do a comma, else, colon, this won't. And then when we hit enter, we'll see this will be seen. Now pay close attention to both syntaxes. In the keyword list format, we separate each key value pair with commas, and each key is followed by a colon. In the do blocks, we get rid of the colons, the commas, and separate each keyword by a new line. They are useful exactly because they remove the verbosity. I don't even know. Verbosity, I don't know, whatever. When writing blocks of code, most of the time you will use the block syntax, but it is good to know they are equivalent. I do like using shorthand version for very short expressions. So if you have an if else block and it's really short, or if you have a function that just returns like an atom or something, I prefer the shorthand version for sure. All right, so this plays an important role in the language as it allows Elixir syntax to stay small but still expressive. We only need a few data structures to represent the language, a topic we will come back to when talking about optional syntax and go in depth with when discussing metaprogramming. With this out of the way, let's talk about maps. Let's see if we have any questions rolling in. Nope, not currently. I'm so bummed chat isn't working. I should turn it off so it doesn't annoy me. All right, so whenever you need to store key value pairs, maps are the go-to data structure in Elixir. A map is created using the percent and then opening and closing curly braces. So this is the map syntax, okay? So we can create a map. We'll just create a variable called map. And then if we do a percent and then opening curly braces, we can set a key here. And then we can put a value. And then we can also have a key not be an atom. So we can do that. So 2, and then we can return an atom. So the values can still be anything like a key value list. But what's different between a map and a key value list is keys can be any value. So when I hit enter, we get our map back. And then we can access our values like this. And we get 1 back. And then we can access our second value like that, and we get our atom B back. And then if you try to access a key that doesn't exist, we just get nil back. So compared to keyword lists, we can already see 2 differences. Maps allow any value as a key, okay? Maps keys do not follow any ordering, okay? So in contrast to keyword lists, maps are very useful with pattern matching. When a map is used in a pattern, it will always match on a subset of the given value. All right, so as you can see here, if we pattern match to an empty map, and then we create a new map here, and we say atom A, value 1, key 2, value an atom of B. And when I hit enter, we get that map back. And then we can also pattern match where we got, with a list, if the value didn't exist or if the length didn't match, pattern matching would fail. We'd get a match error. So now we can do this on the left-hand side. As long as the key is available, we can match to it. So that's pretty cool. And now value A is 1. So we have a map that is more than 1 value, pattern matching to a map looking for just 1 value. Now, if you try to pattern match, though, to a key that doesn't exist, you will get a match error. So if we try to look for C, we get our match error. So I'm going to clear that now. All right, so as shown above, a map matches as long as the keys in the pattern exist in the given map. Therefore, an empty map matches all maps. So that's what happened up here. The empty map matched, and we got our entire map back. The map module provides a very similar API to the keyword module with convenience functions to add, remove, and update map keys. All right, so we have functions that we can get, add, and change a map to a list. So let's go ahead and mess around with those. So we can go map.get, and we can pass a map in. So we can have our value A 1 and then our key 2 with a value of atom B. And then we can get a value as the second argument here. We can just pass in the key that we want and we'll get the value. Did I type something wrong? Oh, yes. I need to close the parentheses. So we get our value 1 back from key. So we can get it. All right. And then we can also add values to our map using map put. So we can say map.put, and we can do the same thing here. We're going to have A1 and then 2 atom B. And now put will insert, so we can say we want to insert the key C with value 3, and then close those parentheses, and now we'll get a map back with the third value. And now, like you can see, it popped up in the middle. So we don't have control of the order of a map. So if order matters, you have to use a list, but if it doesn't matter, maps work great. And then we can also say map.toList, and we can convert our map of atom A to atom B, and then we can convert this to a list. So we get back our key value, our keyword list. So pretty cool. All right, maps of predefined keys. In the previous section, we have used maps as a key value data structure where keys can be added or removed at any time. However, it is also common to create maps with a predefined set of keys. Their values may be updated, but new keys are never added or removed. This is useful when we know the shape of the data we are working with, and if we get a different key, it likely means a mistake was done somewhere else. We define such maps using the same syntax as in the previous section, except that all keys must be atoms. Okay, so if we make a map variable here and we create a new map, and this time our key is going to be an atom name with a value of a string John, and then a key, an atom age with a value 23. And we get that back. So as you can see, the printed result above, Elixir knows, or Elixir also allows you to write maps of atom keys using the same key value syntax as keyword lists. When the keys are atoms, in particular, when working with maps of predefined keys, we can also access them using the map.key syntax. So this is a lot more popular. So if you use atoms in your map, we can now do map.name, and we get John back. And we can do map.age, and we get age back. Now, if the key is not found, let's say we have a typo here, we get a key error. So age with double E is not found. There's also a syntax for updating keys, which also raises if the key is not yet defined. So let's clear that. So it's a lot easier if you're using atoms as keys. Instead of doing like .put, we just have to simply do this. We just create a map outside, and we pass our map in, and then we use the cons operator, and we can say name, and then we can change that value to Mary. So what's happening here is it will match our key name and update the value from John to Mary. So that's cool. And if we try to update a value that doesn't exist, so age with a typo, and then hit enter, we still get our key error. All right, these operations have one large benefit in that they raise if the key does not exist in the map, and the compiler may even detect and warn when possible. This makes them useful to get quick feedback and spot bugs and typos early on. This is also the syntax used to power another Elixir feature called structs, which we will learn later on. Elixir developers typically prefer to use the map.key syntax and pattern matching instead of the functions in the map module when working with maps because they lead to an assertive style of programming. This blog post by Jose Vallam provides insight and examples on how to get more concise and faster software by writing assertive code in Elixir. Let's check it out. All right. Functional languages are typically great languages for writing assertive code, and Elixir is no exception. In this blog post, I would like to discuss some anti-patterns I have seen in Elixir code and how to rewrite them to make them the best. All right, cool. I'm going to add this link to the description in below because this is probably a really good read. Yeah, cool. All right, nested data structures. Hey, what's up, guys? Good to see you. I got to keep an eye on the comments. I lose track. I get into the documentation. I don't know if I'm going to say this right, but Chris Wharton and Tamer, nice to see you guys. All right, so nested data structures. Often we will have maps inside of maps or even keyword lists inside of maps and so forth. Elixir provides conveniences for manipulating nested data structures via the put in arity2 and the update in arity2 and other macros, giving the same conveniences you would find in imperative languages while keeping the immutable properties of the language. So imagine you have the following structure. Okay, so we have a list. We have a keyword list of 2 maps. All right, let's go ahead and get this thing made. I'm going to clear this. Whoops. Clear this. All right, so we're going to create a keyword list called users. And inside of this, we're going to have a key John. And that is going to have the value of a map with name, John, age 27, languages, and we have another list inside of this. All right. So Erlang, Ruby, and Elixir. Good man. And then we'll close off this map. And then we're going to add another user with a key Mary. And she also has a map of her own data. So her name is Mary. Age 29. Languages. Oh yeah, Elixir is first. Cool. She's even better. F sharp. All right. And Klajor. I can't talk today. I blame being sick, guys. All right. And then we'll close off that map. And then we want to close off this list. And boom, now we get that list back. So now we have a keyword list of users where each value is a map containing the name, age, and a list of programming language each user likes. If we want to access the age for John, we could write users, pass in John in square brackets, and then we can say .age. All right, that's pretty cool. It happens we can also use the same syntax for updating the value. So if we wanted to say, so our users list, if we used put in and then users, and we want to update John.age, we can now change his age from 27 to 31. So that's pretty nifty. All right, and then we have the update in arity2 macro, similar, but but allows us to pass a function that controls how the value changes. For example, let's remove Klajor. Why are they doing this to me? From Mary's list of languages. All right, so we're going to remove this. And we can do that by, we're going to rebind our list users, and we're going to say update in, and then we pass in our users list, and we want the keyword, we want Mary dot languages, Okay, now languages is a list, so we have to pass in an anonymous function here. So we're going to do fn, and then we have languages, and then we're going to do our list dot delete languages, and we're going to match. There we go. And then end. And then that's going to remove that from Mary's list of programming languages. Pretty cool. So as long as things are nested and embedded, you can kind of just work your way through and access them exactly how you access values. So we accessed Mary from the keyword list with the function matching. And then we can do the dot syntax for diving into the map, which is pretty cool. There's more to learn about put in Arity2 and update in Arity2, including get and update in Arity2 that allows us to extract a value and update the data structure all at once. There are also put in Arity3 and update in Arity3 and get and update in Arity3, which allow dynamic access into the data structure. So in summary, there are two different data structures for working with key value stores in Elixir. Alongside the access module and pattern matching, they provide a rich set of tools for manipulating complex, potentially nested data structures. As we conclude this chapter, the important thing to keep in mind is that you should use keyword lists for passing optional values to functions, use maps for general key value data structures, and use maps when working with data that has a predefined set of keys. And in the next section, we're going to talk about modules and functions. So that'll be fun. So cool, guys. That was a lot of fun. We learned all about our keyword lists and maps. And let me just pull up that my cool cheat sheet again, because yeah, I'm just doing the final tweaks here, and I'm going to make this available for download in the next day or two, so that'll be cool. This is my little cheat sheet of things that I use daily, and I think it looks pretty cool. I tried to make it look cool and organized and clean without too much stuff, but enough to be very helpful. So I think that'll be cool. Tamer, yeah, it is a big day tomorrow. You should definitely prepare questions for Jose, because we're going to be live. I'll be able to read your chat. I've been preparing all week for it as well, so I can keep the conversation going. I don't think we'll have a problem with that, though. So I think it's going to be a lot of fun. I'm excited. Definitely my biggest guest. I think it's the biggest guest you can have in Elixir. So I'm very lucky that Jose is joining me, and I think it's going to be a lot of fun. Thanks, Sasha. I do too. I really hope I don't wake up sick tomorrow. I don't want to be sick when I have to chat with Jose. So who knows what will happen though. But all right, guys, thank you so much. I appreciate you all being here. And oh, thank you, Antoine. That's awesome. Thanks. And yeah, guys, I'll be live tomorrow at 10 a.m. Mountain Standard Time with Jose. I don't even think I'll have to introduce the man, but I'm very excited. I'm excited to meet him and, talk Elixir for an hour or however long it goes. I guess we'll see. But all right, guys, thanks a lot, and I will see you guys tomorrow.
Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.